National Electrical Code Section 427.22 does not require ground fault protection, often abbreviated as GFP, for a 6 kilowatt water bath heater. It is important to understand the scope and limitations of specific sections within the National Electrical Code, or NEC, to ensure proper and safe electrical installations. Section 427 addresses fixed electric heating equipment for pipelines and vessels. Within this section, Part 3 focuses on resistance heating elements. However, the specific text of 427.22 references only electric heat tracing and heating panels. To determine if ground fault protection is required for a particular application, it is essential to carefully review the wording of the applicable code sections. In this instance, the code language explicitly mentions heat tracing and heating panels and does not include water bath heaters. A water bath heater is distinct from both heat tracing and heating panels. Therefore, Section 427.22 does not apply to it. The code provides specific definitions and classifications for different types of electrical equipment, and it is crucial to adhere to these distinctions when interpreting and applying code requirements. In this scenario, the water bath heater is controlled by a 3-pole across-the-line starter. This type of starter is a common method for controlling electrical motors and heaters. It provides a simple and direct means of switching power to the load. However, a standard across-the-line starter typically does not incorporate ground fault protection. Consequently, if ground fault protection is deemed necessary for the water bath heater based on other applicable code sections or specific installation requirements, it must be provided through alternative means. One option is to use a ground fault circuit interrupter, commonly referred to as a GFCI breaker. A GFCI breaker is designed to detect ground faults, which occur when electrical current leaks to ground. When a ground fault is detected, the GFCI breaker quickly trips, interrupting the flow of electricity and reducing the risk of electrical shock or fire. Another option is to utilize a GFCI receptacle. A GFCI receptacle functions similarly to a GFCI breaker, but it is installed at the point of use, providing localized ground fault protection. GFCI receptacles are commonly used in areas where there is a higher risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The decision to provide ground fault protection for a water bath heater should be based on a thorough assessment of the specific installation conditions, potential hazards, and applicable code requirements. It is also advisable to consult with a qualified electrical engineer or inspector to ensure compliance with all relevant regulations. Ground fault protection is a critical safety measure that helps to prevent electrical shocks and fires. By understanding the different types of ground fault protection devices and their applications, electrical professionals can ensure the safe and reliable operation of electrical systems. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect advancements in technology and changes in industry best practices. Electrical professionals must stay current with the latest edition of the NEC to ensure compliance and maintain a high level of safety. Understanding the terminology used in the National Electrical Code is essential for proper interpretation and application of the code requirements. Ground fault protection is a term that refers to a system designed to detect and interrupt ground faults. A ground fault occurs when electrical current flows through an unintended path to ground. This can happen when insulation on a wire fails, or when a conductive object comes into contact with a live electrical component. Ground faults can be dangerous because they can cause electrical shocks and fires. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shocks caused by ground faults. GFCIs work by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out of the circuit by a small amount, the GFCI will trip, interrupting the flow of electricity. GFCI breakers are installed in electrical panels and provide ground fault protection for an entire circuit. GFCI receptacles are installed in place of standard electrical outlets and provide ground fault protection at the point of use. The National Electrical Code requires GFCI protection in certain locations, such as bathrooms, kitchens, and outdoor areas. This is because these locations are more likely to have wet conditions, which increases the risk of electrical shock. The NEC also specifies requirements for ground fault protection of equipment. These requirements are intended to protect equipment from damage caused by ground faults. Ground fault protection of equipment is typically provided by ground fault relays, which are devices that monitor the current flowing through a circuit and trip a breaker if a ground fault is detected. Ground fault protection is an important safety feature that helps to prevent electrical shocks, fires, and equipment damage. By understanding the principles of ground fault protection and the requirements of the National Electrical Code, electrical professionals can ensure the safe and reliable operation of electrical systems. In summary, while NEC Section 427.22 does not mandate ground fault protection for 6 kW water bath heaters specifically because it pertains to electric heat tracing and heating panels, it's crucial to assess other applicable code sections and installation conditions to determine if GFP is required for safety and compliance. If needed, alternative methods like GFCI breakers or receptacles can provide the necessary protection.